Welcome to my channel. I'm Zhang Jingxu. Let's talk about problem 34 in chapter 2. This problem is a little bit difficult. You tell us this shows that the average velocity equals to initial velocity plus final velocity divided by 2 is not valid if this acceleration is changing with time t. So where a and b are constant. In this one, we can draw a VT graph. Show how it works. First one, let's say this is a VT graph, right? VT graph. We can say, for the constant velocity, it looks like this one. The acceleration is constant. It's always moving. The velocity just speeding up at a constant acceleration. And for this blue line, it is a variable acceleration. The acceleration kept changing, right? The acceleration changing with time because at each point of time the slope is different. In this case, if we want to find the average velocity for this orange line, we can consider it's we can say the displacement for this triangle. This one, see, it is 1, right? This side is 1. This side is 3, so 1 times 3 divided by 2, how much? 1.5, 1/2. So the displacement on the VT graph is the areas under the line. So this is 1.5, agree? 1.5. So then we use the total displacement divided by time taken, 1. The average velocity is 1.5, is 0. We see for constant acceleration, this 1.5 just at the middle of this 0 to V0 to V, agree? So this one is just at the middle there. So this works for the acceleration is constant. But however, let's look at the acceleration changing with time for this blue line. For this blue line, we can say because acceleration kept changing with the time. So the displacement for this blue line is smaller than 1.5. Do you agree? Because this part doesn't count. This part doesn't count. So its displacement for this blue line is smaller than 1.5. And then let's consider the total time it taken is 1 second. So the average velocity for this one less than 1.5 divided by 1, the average velocity must be 0. Agree? Smaller, around 0. And this one, so the average velocity for this changing acceleration, this blue line is not in the middle, so this one is not valid. This is from the picture. We can understand that on the VT graph. Another way we can solve the equations, see how it works. Because we know the acceleration is changing with time, so acceleration is derivation, dv and dt, and then a plus bt, right? Then we can do the integral. And the initial velocity is v0, the final velocity is v. Initial, the time t is 0 and 2t, and then we do the integral. We find the velocity function looks like that. It is changing with time t. Agree? Yes. And keep going. Because the velocity is the derivation of the displacement, so dx, dt, and then we put it there, and we do integral again. And we find the displacement function look like this one. This one. So we must remember, this is a displacement function for this changing acceleration. And for this one, next thing, if we want to find its average velocity, so it is displacement divided by t, right? Displacement divided by t, it equals this one. So the left hand side is this one. The average velocity is this one. And then we consider the right hand side of the equation. The right hand side of the equation is the initial velocity plus final velocity divided by 2, and then we put this v inside. We find it equals to this one. So see, these two are not equal because this term is not equal. Which one is smaller? This one, right? This one is smaller. The average velocity is smaller. Agree? Yes. Okay, thank you. That's all.